Guys, today's video is a little bit more talking about the unit circle. This is the continuation of the last part of this page's notes at the bottom. Let's read this together. Let theta be an angle in standard form, and P of the point x comma y is a point on the terminal side of theta. That means if we have an angle, it starts right here and it finishes over there. This point that's on the end of, right there, let me pick a different color, right here, this point is what we're looking at. You go over on the x-axis, x amount, and then you go up y amount to reach to that point. Doing this creates a right triangle, looking like this, where not only do we have over x and up y to get to that point, but we also create a radius, which is the same thing as your hypotenuse of that right triangle. From the Pythagorean theorem that we know that a squared plus b squared equals c squared, we're going to come up with a different Pythagorean theorem. Instead of a, b, and c, we're going to write down x, y, and r. So a and b in this case are x and y. And instead of c squared, we're going to label it r for the radius. So now we're going to come up with a couple ratios and fractions about this triangle. Here's my angle, here's theta. Okay, ignore this theta, we're talking about theta right there. From that, let's come up with what sine is: cosine, tan, cosecant, secant, and cotangent. Okay, here's my theta. Oops. There's theta right here. And the sine is opposite over hypotenuse. So in this case, its opposite is y, hypotenuse is r. Cosine's adjacent over hypotenuse. Tangent is opposite over adjacent. And then cosecant is the flipped of sine. Secant's the flipped of cosine. And then cotangent is the flipped of tan. All of these ratios reflect this point, making this right triangle. Let's look at an example. Here we have the point 5, -2, and I'm always going to give you the point in terms of any problem. So let's graph 1, 2, 3, 4, 5, and then -2. So we went down -2, we went over 5, make a dot, and then we're going to connect the dot to the origin. And making a right triangle, your right triangle is always going to connect with the x-axis. Here's the right angle right here. And your theta is always going to be from the origin. Here's your theta right there. From theta, we can come up with sine, cosine, tan, and then the reciprocal functions as well. Sine, I'm going to write -2 is the opposite. But we don't know the hypotenuse. We don't know the radius, the r right here. We're going to use Pythagorean theorem to find what the radius is. It doesn't matter which one's x or y. 5 squared plus -2 squared is going to be the radius squared. 25 plus 4 is the radius squared. So that means the square root of 29, and you could just leave it as the square root of 29, is the radius. I'm going to erase r now, and I'm going to put the square root of 29 right there. Now it's just filling in the blanks. The sine opposite over hypotenuse. You do not need to rationalize, don't worry about it. Cosine adjacent over hypotenuse. Tan opposite over adjacent. And then you could just do the reciprocals for the other functions. and then tan would be 5 over -2. And don't forget the negatives here. In this case, a lot of mistakes you may make is labeling these ordered pairs. In this case, the 5 is positive because we're going right 5, and the 2 is negative because we're going down 2. Another mistake, like I told you you would make, some of you might make a right triangle using the y-axis. Make sure it's connected to the x-axis, and make sure your theta is always coming from the origin. That's where you start. Write down what questions you have about doing these 6 trig functions from an ordered pair, and see everyone next time.